Thank you, Phil. That was so great and so wonderful to hear and learn. I'm going to open it up to questions. We have multiple microphones roaming around. I'll start in the back and then come back to you, Jeff.
Fabulous presentation and research. Most of what you talked about early on was hearing people and the functions of the left brain hemisphere in those individuals. So let me ask you two related questions about deaf people. The first one, might the occipital effect you're getting be related to using visuospatial skills that are genetically represented in the right hemisphere and being repurposed for language since they can't use the auditory pathways? So that's number one. Number two, if this occipital effect is real, why is it that deaf aphasics lose the ability to understand sign language, just as hearing aphasics have difficulty reading language or spoken or written language? So, thanks.
Those are questions for Karen, right? Not for me. So, yeah, those are tough questions, and I don't have really good answers for them, as I guess would be the bottom line. But it's clear that yes, if that area is real that we're seeing, and this is one study, right, and we've got other data that hopefully will support it. Yeah, it suggests that something like what you said, maybe the visual spatial possibility, yeah, maybe that system that I showed you for the early NP150, which was pretty much in that same area initially, could also be partly responsible, right? So that the part of the system that is optimized for object recognition might be, in fact, more salient in that particular population. As for the deaf aphasics with sign language aphasia, I mean, presumably the language areas that represent the early part of sign processing would probably be very different from what we're talking about here with written English. So it wouldn't surprise me at all, right, that the brain areas that are involved in ASL aphasia are different than the ones that we're seeing in these particular paradigms. But I actually don't know much about ASL aphasia. Karen, do you want to say anything? Okay.
Thank you. Is reading processing different and more pictographic languages like Chinese? Yeah. And also, I think of my kids communicating to me with a mixture of words and emoticons.
Very, very good question. Yeah, so yes, obviously what we're talking about here are alphabetic languages, and presumably some of the same kinds of recycling must go on in other non-alphabetic languages as well. It's certainly the case in Chinese that Chinese is actually taught, to read Chinese is actually taught with a facsimile of what we use. They actually have an alphabetic, I don't know what they call it, pinyin, I believe, that they use for actually learning it, because it is really hard to go from these pictographs, right, to directly to words, particularly for early learners. So the answer would be that, I mean, I guess the great part about neural recycling is, right, is that what gets recycled is probably largely dependent on the underlying stimuli that are involved in the particular domain. So it's letters and alphabets that happen to get recycled in letter-based languages that map on to sound. But it would probably be something different, I would guess, probably in other languages that don't use that same system. And what it underlies is this flexibility of the human brain, particularly the young human brain, to basically, the plasticity of it, to basically adapt to a new type of stimulus environment. And it's obviously important that this happen early in life, right? Becoming literate later in life, by the way, is much harder. Children learn to read, although they struggle, right? It's harder to learn to read as an adult if you've never read as a child. So it does underline, I think, the fact that what we're talking about here is a very plastic system that particularly early in life is very malleable.
Two questions.
Yeah. Having worked with children with various disabilities, my thought was, and I was really intrigued by your fourth bullet, you know, students who are blind, and yet they can hear the language, but then with Braille, and is there any research there? And the other thing is that having worked with children who, it's one thing when you're learning to read and you've been taught one language, and then when you look at dual language learners, some learn it simultaneously and some children learn it sequentially. And that's very, very different because Spanish is so phonetic based, much more than English. Do we have any research in that area? Because we have more and more children, you know, I'd like to see the generalizability, or do you know the generalizability fundings with these different student demographics?
Yeah, so I know a lot about Spanish because we have colleagues in Spain at the Basque Institute for Language, the BCBL, I believe it's called, yeah, that do very similar studies. In fact, most of what we've done in English, they've done it in Spanish, and they also do it in Spanish, English, Catalan, bilingual users. So yes, the basic phenomena are the same. There are some subtle differences, probably due to the fact that, like you said, Spanish is much more transparent than English, right? The sound to letter relationships are much stronger, and this is probably one of the reasons why dyslexia is much more prevalent in English-speaking cultures than in cultures where the transparency is much better.
What about children that are blind?
Yeah, the blind question, yeah. Yeah. Yeah, there is. Bridget Roeder in Germany.
Maybe repeat the question.
Yes, oh yeah, sorry. Yeah, the question was whether there's similar research going on in blind individuals. One of the challenges in studying something like reading in the blind is, of course, you have to use Braille. And Braille is a challenging stimulus to actually record to, right? When people actually feel the bumps that they're feeling. We actually tried to do that when I was a postdoc here in San Diego. Years ago, we tried to figure out a way to do that, but could never manage to do it. I'm sure someone has. Has Bridget done any of that work, do you know?
I know the fMRI, there's a lot of recent work.
Yeah, yes.
So the visual word form area gets activated.
Yeah. Braille might be better in a lot of ways because Braille actually is processed much slower than spoken or written language. So you could slow down the process, right, and perhaps make it more amenable for study.
Phil, maybe this is a subset of that last question, but when you think of spoken word or even sign language, emotion can come out in a single word.
Sure.
And imagine that would it generate a different stimulus. And if you'd learned the word first, verbally, then it would influence how your brain responded to it as a flat set of letters, versus if you only see the letters, which rarely convey emotion.
Yeah, no, it's true. It's much harder to convey emotion with words, right? You have to do it with sentences and with tone of how the sentences unfold. And of course, good writers know how to do this. But yes, individual words, it's much harder to do this, right? Because yes, we have something in spoken language called prosody, which allows us to change the emphasis on words and to basically manipulate emotional and other kinds of information. We've done some work with spoken language, and we've done a little bit of work with emotion, but I don't have a good story for you about that particular dimension, how it might differ between written and spoken language.
Okay, well, people think about. While you think of a question, I was going to ask the pathway that was shorter, yes. Right? Is there a reason somebody would not develop it, or does it relate potentially to people who are fast readers versus slower readers, even in adult? Because you said you pick it up in teenage years. About, is there any data on whether those who are slower readers have not picked it up?
Yes, so that's a very good question, and I'm pretty sure the answer. I can't say absolutely because again, we've not been able to actually go into the brains and figure out what's happening in individual people. But my guess is that, yes, slow readers typically probably don't read as much. And developing that second pathway requires lots and lots of practice. You have to be a voracious reader of sorts in order to become the expert, skilled reader that we're talking about here. So people who read very infrequently or struggle with reading probably rely more on that auditory route that I showed you. And that's probably one of the reasons why maybe they don't like reading as well, right? Is it's slower and more effortful for them.
Thank you. Any other questions from our audience? Okay. Well, thank you so much for your time.
Yeah, you're welcome.